Hello everyone, welcome back to FX021. So in this lesson I'm going to teach you how to make the plants moving with the wind. So I'm using the Quixel assets. If you have the Megascan plugin installed, then if you just download the assets and it will just import automatically with the correct material. So I just find 3 of them from the Megascan. So this is first, this is the second, and this is the third one. Okay. And before I do the simulation, I post-process these assets a little bit. So if you look closely, when we do the wind simulation and we want move these plants, we want to make sure these roots are not moving, and the roots are glued to these leaves, and they are all affected by the wind, right? So if it's in a production, then usually these assets are built from Maya or something, some other 3D package. They will have the name attribute or path attribute so that you can split the root and the leaves. Okay, but seems like if we look at the information here, seems like the Quixel doesn't have the it does have the name attribute, but you cannot split it, because if you look the geometry spreadsheet here, go to the primitive, if you see the name attribute, it's called LOD1 variation 11, right? And all of them are the same, so they don't have like leaves variation 11 LOD1. So basically you can't split the root and leaves, but we need to, when we do the Willem simulation, we need to have these roots group. So how we split it? So if you see these, go to the wireframe mode, you can see these leaves are pretty low polygons. So you can count there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe 11 for these leaves. So we can split them by the polygon count, okay? So if we do for each connected pieces here, go to the visualize here, and if we change this to single path, you can see this is it's looping through every leaves, every roots. So yeah, we're gonna do some code inside the loop. So what I do is this. So if the number of primitives, which is the poly count on these leaves, is not equal to 8, also not equal to 12, also not equal to 14. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12. Then it's root. Okay, so I make sure only the root are selected. So I think there are 3 type of leaves scattered on this Quixel plants. So they are like 8 polygons leaves, 12 polygon leaves, and 14 polygon leaves. So other than that, these the rest are all the roots. So that's how I split this. Okay, so if we check the out node here, and if we go to here, you can see the roots and not in the group. Okay, so if we use a blast node here, point root, see, these are all the leaves, and delete not selected, these are the root. Okay, so that's how you split them. And I did the same thing for these 2, but the poly count may be different on different plants. So yeah, so just copy and paste, and do for all these 3 assets. And also I have a custom variant attribute here. So 1, 2, and 3, these are attribute we're gonna use later when we scatter these plants. Okay. So now we can do volume simulations. So what I do is I get the assets I just processed. So we got the variant attribute, and we also have the root point group here. Okay, so it's a common volume simulation. So make sure it's the class here, point mass calculator varying, and pretty much, and you can change the stiffness here. Pretty much you can tweak to get best look, and then it's volume constraints pin group. So basically want to pin this roots group so it's not moving with the wind. Okay, it's moving with the wind, but it's not gonna break. Okay, so now the group type, the constraint type is pin to target, and the group type is roots. So this will be pinned, and the pin to animation is soft. So we want it affected by the wind, so slightly, but not like too stiff. So it's like not moving at all. So we want to change it to soft animation, and you can play around with the stiffness and the band stiffness. And then we just glue these leaves and the roots all together. And in the volume solver, this is all default. So just in here I have a pop add vec by volumes. So it's the velocity field from the wind simulation. And I just play around with the velocity scales here. And then I just pack the geometry and the constraints and cache it. So I do it for all these three variants, and I did for I think I did for 168 frames. So the frame range is 120, but I did 168 because my wind simulations also did. I think I also did 168. So I time shift 48 frames. So the first frame is the 48 frames. So it's kind of like a pre-roll for 2 seconds. So I also did it for the plants. So I time shift 47 frames. So now it's already moving at the first frame. Okay, and also I transfer the variant and the shop material path from the one I import here. So later when you render, you can have the material, and also when I scatter, I make sure I have the variant attribute here. Okay, so I did these for all these three things here. And also this one I just time shift a different value, so it's not too uniform when we scatter. So it's not all these plants are start from the same frame. So I just make sure they start at a different frame, so kind of like fake it like there are many of different simulation of the plants. And now we just merge all these together, and they all has the variance attribute. So now we get the terrain here, and get the road, and I just want to make sure these parts are not scattered, because I don't want the trees or plants are on the road, right? So just do a color, black color for the road, and transfer the CD attribute. You can play around with the distance threshold here. So I just blast the black color here. So now I make sure I only will scatter on this part. Okay, and then I just attribute pin. So I just manually paint the mask attributes, so these part are where I want my plants to be, so they will have a mask attribute here. Okay, and then I just scatter on these based on the density attribute. So the density attribute by default is C, I think it's called density, but we have our mask attribute, so we just overwrite with the mask. So then these points are on the mask, and I turn off the relax iteration so it's not too uniform. And I just plug into the scatter line. And because we already have these points scattered, so scatter line, we just want to add attribute to the existing point cloud. So we want to get the feature like rotating around normal, max rotation angles, these things here. So now you can see they are not scattering the new point. They're using our scatter point, but they adding this orient attribute on it. Okay. Before they don't have these attributes, now they have. And we just make sure we have these so we can rotate. Okay. And then we randomize the p scale. So the p scale decides how big is our plants. And then attribute from pieces, we get our first input is our point cloud, so this point. Second input is our geometry library. So this is all merged together, our geometry library. And I just plug into the second input using the variant attribute I just created. And then copy to point. It's the geometry on the first input, point cloud on the second input, and also using the variant attribute here. So now they have, you see, different p scale. If you want to change the size, you can here, right? If you want to change the max size, yes. And in the scatter line, you can play around with the, the blend normal with Y. So it's all the way up, or it's not. Or you can play with the random rotation angle. And also the max angle here. So you don't, one thing you need to notice that is you don't want to rotate too much. So basically I do it from 1 to 50 because we already simulate the wind goes this direction, okay? So if you rotate too much, then it's going this way and scatter, so it feels like the wind is different. One is going the X direction, one is going to the negative Z direction, one is going to the positive Z direction, so it feels like a weird. So make sure the rotation angle is relatively small. And then yeah, that's it. So now you got all these plants moving with wind. It's pretty slow, but yes. Make sure you have you can't have pack and instance, but I just turn that off because I haven't scattered too much. So yeah, that's it for today. That's how you do the volume simulation in Houdini. See you next time.